All right, so it's called linear equations in one variable. It is exactly that, linear meaning it's not squared, okay? One variable meaning you're only going to see the one variable. So the goal here is to isolate the variable. So you want to get it by itself on one of the sides, okay? There are special cases, which we're going to talk about in a minute, which are, one, if the left side and the right side of the equal signs are equal, the answer is all real numbers. So if the variable cancels out, well, it doesn't even have to cancel out. If they are exactly the same on the left side and the right side, so if I had x equals x, I had 2x equals 2x, I have 1 equals 1, 0 equals 0, something like that, okay? Then these equations are all real numbers would be the answer. Any solution would work if you plugged it in. So you'll either write all real numbers, you'll see ARN for all real numbers, or some books do like a fancy R, like that, okay? I'll check how WebAssign does it. I actually don't remember. If the variable cancels out and what's left is a false statement, then it's no solution. So a case like that would be something like 1 equals 0 or 5 equals 2, okay? If there's no variable left and what's left is a false statement, then it's no solution. All right, so let's start. We go basic, just solving the equations. So for number 1, what are we going to do? Add the 6. 3x, this is gone, equals 6. Then divide by 3. The great thing about all of these is you can check every single one of these answers by plugging it back in. So if I have extra time, I take that 2. I plug it back in here. I'd get 3 times 2 minus 6 equals 0. 6 minus 6 equals 0. And 0 equals 0. So every single one of these can be checked. What would be step 1 for 2? Okay, and there's 2 options. You can either subtract the 3x first, or what else could I have done? Subtract the 4, right? You could go either way. So this becomes 2x plus 4 equals, this is gone, negative 8. Now subtract the 4. 2x, this is gone, equals negative 12. Divide by 2. X equals negative 6. Okay, if it's all real numbers, then a WebAssign says to write the word reals. Just like that. It says it. It says it in the directions, but just to clarify, okay? For 3, what do I have to do? I can subtract the 7. I get negative x equals 12. Then what? Divide or multiply by negative 1. Either way, it's going to get rid of the negative on that side and bring it to the other side. Easy stuff. Yes? Okay, you do the right side. All right, so 4, we subtracted the 1. 7x equals 21. Divided both sides by 7, you get x equals 3. Number 5, you can subtract the 3, and I get 5x equals 3 minus 2x. Add the 2x, 7x equals 3. Divide by 7, and it's 3/7. You'll leave it just like that. Don't try to put these in decimal format. Don't try to round them, nothing like that. Keep them in their exact fraction form. 6, I subtracted the 7. Negative 2x equals 8. Divide both sides by negative 2, and I get x equals 4. Good on these. Yes? Yeah. It's negative 4 because this should be a positive 8, and then we divide both sides by a negative 2. All right, then 7, you can subtract 5x from both sides. I get 2x minus 9 equals 7. Add the 9, 2x equals 16. Divide by 2, and x equals 8. Good? Good. All right, then we get to ones with parentheses. So we're using the distributive property here. Every number that's on the outside that's getting multiplied by that parentheses is going to get distributed in. So this becomes 6x minus 6 plus 4 equals, distribute here, 21x plus 3. On the left, I'm going to combine together the negative 6 and the 4 before I move it. So it would be negative 2 equals 21x plus 3. Then I can subtract the 6x. Negative 2 equals 15x plus 3. Subtract the 3. And divide by 15. We're going to always reduce these fractions, so this would be negative 1/3. Number 9, I'm also going to distribute, so 4x plus 8 minus 12 equals distribute 5x minus 30. Combine the like terms on the left-hand side. Subtract the 4x. Add the 30. And x equals 26. Still good? Yeah? All right, you do 10 and 11. All right, so for 10, we're going to distribute the 3 in. I get 6x minus 12 equals 7, and then the negative goes to both of these. So it's a really common mistake. Be careful. Negative x and then negative 5. Combine the like terms on the right-hand side. I'd get 6x minus 12 equals 2 minus x. And then I added the x. You could either subtract the 6x or add the x. It doesn't matter. You get 7x minus 12 equals 2. Add the 12. 7x equals 14. And then divide both sides by 7. And you get x equals 2. Questions on that one? All right. 11. We're going to distribute the 4. So I get 4 times negative 2. Negative 8. 4 times 1, which is 4, equals 6. Distribute the negative again to both. Negative 2. God bless you. Positive 4. Combine your like terms on the right. Negative 8x plus 4 equals 10 minus 2x. And then I added the 8x. You could either add the 8x or the 2x. It doesn't matter. And then I get 4 equals 10 plus 6x. Subtract the 10. Negative 6 equals 6x. Divide by 6. And I get x equals negative 1. Still doing good? Yeah. Okay. 12 is the first one that's got fractions in it. So you actually have options here. You could distribute that 1/5 and deal with the fractions along the way. Or my advice is multiply by the least common denominator and get rid of that fraction right away. So identify all the denominators in the entire equation. There's a 5 and a 3. What would be the least common multiple of 5 and 3? 15. So I'm going to multiply my whole equation by 15. Now this affects everything that's not in parentheses. So this 15 is going to get multiplied by the 1/5, and I'm going to change that to 3. I get 3. Parentheses 2x plus 5. This 15 does not go inside the parentheses because we change the 1/5 and that then gets distributed in. The 15 does get multiplied on the other side over here though, and 3 goes into 15 5 times, and that 5 is going to get multiplied times both the x and the positive 2. So be really careful there. Make sure the 5 goes to both. Now I distribute. 6x plus 15 equals 5x plus 10. Subtract the 5x. X plus 15 equals 10. Subtract the 15, and x equals negative 5. Yep.
Multiply like the first side by 15. What if you multiply by 3?
So you have to do the denominator that they both go into, because we can't multiply just half of my equation by something and the other half by something. It has to be this, the whole thing gets multiplied by the same number. So once you find out what that least common denominator is, it's got to be of all of them. And you multiply the entire equation by it. You can't just do half and half. Questions on that one? All right, let's look at 13. Now we've got more denominators. So what's the least common multiple of 3, 2, 4, and 3? 12, okay? The easiest, and if you don't catch it right away, get the biggest number and do multiples of that. Because it may not be multiply it all out. It could be, but it doesn't, right? So 4, obviously, they don't all 3 go into 4. 8 would be next. They don't all 3 go into 8. 12 is next, and that's the first thing that 3, 2, and 4 go all into, right? So that's what I'm going to multiply everything by. There are 4 fractions here. We're going to multiply it 4 times. So 12 is going to get multiplied by 2x plus 4 over 3, plus 12 is going to get multiplied by 1/2 x, equals 12 is going to get multiplied by 1/4 x, and minus 12 is going to get multiplied by 7 over 3. You don't have to do this step every time. Just be really careful and make sure it goes to all the parts. So 3 goes into 12 4 times. 2 goes into 12 6 times. 4 goes into 12 3 times. And 3 goes into 12 4 times. The goal there is to have no fractions left. Now this 4 is going to get multiplied by both the 2x and the 4. So this is really 4 times 2x plus 4 plus 6 times 1x equals 3 times 1x minus 4 times 7. I distribute this, 8x plus 16 plus 6x equals 3x minus 28. Combine the like terms on the left, 14x plus 16 equals 3x minus 28. Subtract the 3x. 11x equals, or actually 11x plus 16 equals negative 28. Subtract the 16. 11x equals negative 44. Divide both sides by 11. And x equals negative 4. So again, with extra time, I can take that negative 4 and plug it back into my original equation everywhere there's an x and see if my left side equals the right. That's how you can check these. Sophia.
I'm like confused. How do you know what to subtract it by? Like, the whole thing? You know,
You mean multiply it by?
kind of like cancel it out.
Like for the 12. Like how did I get the 12? Is that what you mean? So I think the easiest way is grab the biggest number that's there and do multiples of that until all the other numbers go into it.
No.
Oh.
Like, the part where it's like 4x plus 16 equals 3x minus 8.
This part?
Yeah, and then you like subtracted it by 3x.
So you can actually, there's so many things that you could do there. You don't have to do the 3x. So at this point, because it's all addition and subtraction, I could either subtract the 14x from both sides. I could subtract the 16 from both sides. I could subtract the 3x from both sides or add the 28 to both sides. The order there doesn't matter. But your goal is to get the ones that have x's to one side and the ones that don't to the other. Does that make sense? So like what would you have done there?
Like, I would have subtracted 14x and then negative 16.
Which is totally fine. Well, but you'd get 16 equals negative 11x minus 28. Then you want the 28 to go on the side with the 16. So you'd add the 28. Then you'd divide by negative 11. You still get that same negative 4. You're welcome. So the order in which you do that doesn't matter. You obviously can't divide before you get rid of move them to the other side. You're doing basically the reverse of your order of operations. Okay, so 14 has decimals and fractions, right? I've got a 0.25 and I've got a 2/3. Ew. What could you do here? I can change the 0.25 to a fraction. I can't change 2/3 to a decimal because it's a repeater, right? It's 0.6 repeated. If that was like a 1/2, I could rewrite it as 0.5x. So you can go either direction. But because 2/3 does not end, it's a repeated number that doesn't end, we can't rewrite that as a decimal, okay? But I can take this 0.25 and I can say that's the same thing as 1/4 x. Now what's my least common multiple, or least common denominator with 3 and 4? 12. Multiply everything by 12. This time I'm not going to multiply it out. I'm just going to show you what would happen, right? So 3 would go into 12 4 times. I'd get 4 times 2x. 4 would go into 12 3 times. I'd get 3 times x. 12 also comes to the other side of the equal sign, and that's the most common mistake made on these is forgetting to do that. It goes all the way across the equation. Yep.
So the only time you don't go all the way across is if it's in parentheses.
Correct. You would even, if there was something on the other side, you would still go across, but if anything that's in the parentheses doesn't get them multiplied. Yep. So this is 8x plus 3x equals 12x plus 24. 11x equals 12x plus 24. I'm going to rewrite it up here. Subtract the 12x. And I get negative x equals 24. Divide or multiply by the negative 1, and x equals negative 24. Questions on that one? So if you can change it to be a fraction, do it. If you can change it to be a decimal, you have two options. But something like 2/3 or 1/3 that keeps going and repeats, you can't use those. Okay, now look at 15. You've got brackets, you've got parentheses, you've got negatives on the outside. What are you going to do first? The parentheses on the inside, okay? So I'm going to go innermost first. I'm going to do 4 stays on the front. 2x, this negative goes to both of these. Minus 3 plus x plus 5 equals negative 7x minus 2. Now what? Good. Combine the like terms inside the bracket. So 2x plus x is 3x. Negative 3 and positive 5, positive 2. Now the brackets work just like parentheses. So I'm going to distribute the 4 in. Add the 7x. Subtract the 8. And divide by 19. They're not all going to be pretty whole numbers. Don't freak out. All right, so for the first one, you would distribute the negative 2. Combine your like terms and you get x minus 8 equals x minus 8. As soon as you get to the point that the left side is exactly the mirror of the right side, you can stop. And the answer there is all real numbers, okay? On WebAssign, it actually tells you to put the word reals in there in all capital letters, okay? So you will type in exactly into the box, R-E-A-L-S, reals. That's your answer. 17... you would distribute the 3, you get 9x minus 3 equals 9x plus 7. When you subtract the 9x's, the variables cancel out. What's left is a false statement. If what's left was true, it'd be all real numbers. But if what's left is false, now it's no solution. And on WebAssign, it says to put DNE for does not exist. Okay? Yep.
Can we also put it down on WebAssign, but like for test and S?
Absolutely. So for a test, I would take either answer. I just know on WebAssign, people really like to get the little green check that shows that they're right. And to do that, you have to put DNE. Yeah. 18, same thing, right? Distribute the negative 6, distribute the negative 3, and what happens is the 15x's cancel, and I get 6 equals 1, which is not true. This would also be no solution. You could literally put the 0 with a slash through it. You could put NRS for no real solution, or on WebAssign DNE for does not exist.
For 17, couldn't you just stop at 9x minus 3 equals 9x plus 7?
Well, you want to just make sure the variables would cancel out. But technically, yes. Then for 19, so for 19, I would say one part of you would want to get rid of the fraction, and you can multiply everything by 2 to get rid of it. But there are scenarios in which it doesn't really hurt to just distribute the fraction, and that's when that number goes into both of the terms inside the parentheses, which is this case, right? Both 6x and 14 are even. So if I just distribute this 1/2, I'd get 3x plus 7 equals x plus 1 plus, distribute this, 2x plus 6. So it's not so bad to deal with the fraction this time. 3x plus 7 would equal 3x plus 7. And again, it's all real numbers or reals for Webassign.
I didn't get 3x plus 7. I got 6x plus 14 because I did the...
But they're the same on either side.
Yeah.
Yeah, it doesn't matter. Yeah.
So I do like multiple...
Yeah. Because you can stop at any point, right? Like I could subtract 3x from both sides and now I get 7 equals 7. Or you would subtract from both sides, you get 14 equals 14. Doesn't matter as long as the left side exactly mirrors the right side. Okay, so we have gotten into Webassign for the book, but now we're going to start to use it for the homework. So everybody's going to do this process with me, okay? You're going to go to Canvas from either the app or the web. It's actually, you're doing it from the app the first time to make sure you're in the class, which I think we all are, right? We've done this before. I know it's been a long time, but we got in there just to get the book before. You're going to go to modules. You're going to find the module that says Webassign. And you're going to click on the second link there that says Webassign Algebra 2 Honors 21-22. And it's going to take you to Webassign. Hang on, wait. If you've already logged in before, remind me, we all did, yes? Yeah, okay. If you've logged in before, I get this pop up. I'm just going to go ahead and go open Webassign a new tab. Or you can go to your settings and you can enable the pop-up. You're going to sign in. Now, this was your email, your Add Students email, right? And then whatever password you came up with. Now, I'm going to jump to Safari.